Hello, my name is Nagsai Purvach, and today my topic is about lidar or light detection and ranging system. Light detection and ranging system. It is used in autonomous vehicles. It is used, and my topic is about how to use the lidar in autonomous driving system. We have to know why we have to use autonomous driving. We can say that the we can see that the human drivers has many problems. Thus, human drivers has many problems for attaining into the attaining into the situations. Thus, we have to use different types of algorithms to use in autonomous driving. We have to use autonomous driving to navigate the vehicles, and so thus to get that we are using different sensors like cameras, radars, etc. Instead of using those cameras and radars, we can also use lidar or light range detection or light and range detection. And we can see this is the typical radar scanner. The lidar uses a small beams of light which transmit around the surface, around the material, and producing different scans, thus producing different scans, and perspective of the around will be used. And this is the prototype. Simple prototype of the vehicle. We can see this is the lidar scanner. On top of the car. This is a simple principle where the pulses are generated. It hits the point, and photo detectors are used, and processes are applied, and the beaming system and the light beaming system produces some kind of image. Now we are going to see how simple lidar can be.
LiDAR is an acronym
This
for
is the lidar
light
system.
detection and ranging. LiDAR is like a radar, except that it uses light instead of radio waves.
We can see here different different formation of different points are generated by using lidar signal. It is similar. Light source is used.
A LiDAR sends out light pulses and measures the time it takes for a reflection bouncing off a remote object to return to the device. As the speed of light is a known constant, the distance to the object can be calculated from the travel time of the light pulse. LiDAR can be one-dimensional, like laser distance meters. It can also be two-dimensional, much like the radars used by ships and traffic control towers on airports. 3D LiDAR exists too, and is used, for instance, by planes to create three-dimensional renderings of the surface of the Earth.
See how different types of lidar systems are used. Simple lidar system is a point source, and next comes the 2D lidar system, and this is the 3D lidar system. The 3D lidar systems can be used to generate different terraforms of the lands
beneath them. By working with one-dimensional first.
Our stoplights.
Rotating 1D LiDAR.
We can
Instead
see
of rotating both
this is
the
a 2D
laser
lidar
and
which
the
is used
detector,
in
it's often
cars.
easier to shine the laser on a rotating mirror. By sending out light pulses periodically, 360 degrees can be made. Note that the reflector from it LiDAR.
See,
It features a range of up to 10 meters and an angular one-dimensional mode. I connected the serial only. The LiDAR then consumes approximately 400 milliamps. For programming the tried old card on relations.
we are going to build
I built
a
simple remote control card on which I mounted the LiDAR. The card has two motorized wheels in the middle and a standoff on either end. I glued ping pong balls cut in half.
Now the control algorithm.
My goal was to program
this is
the
the
card
small
so that
lidar,
it would drive around all by itself without
mobile.
bumping into objects like furniture and things. A popular approach is to let the card run around and back up or steer away when it comes too close to an object. But this requires the card to make decisions. I wanted something simpler. There are many examples of simple algorithms that result in complex behavior. For instance, the way a flock of birds stays together. And I wanted something like that. My idea was to make the cart always move in the direction of the greatest distance as reported by the LiDAR. To avoid making it run in circles, it only looks forward, in the range of 270 to 90 degrees. Implementing this rule was quite easy. For every scan, a table is updated with the average distance for each degree. Therefore, the table has 360 entries, one per degree. This table is then searched. To my great surprise, on its first run with this simple algorithm, the cart managed to move through our living room without bumping into obstacles. It circled our couch. Summarizing, in this video I showed you how I managed.
And this is the system which he had used. This is the simple system which he has used. This is the system. This is the simple system we have used, where the laser is hitting the mirror and the laser spins across the table. And generating different types of waves, and hitting the target and giving the response. And we are using different radars. And keeping it onto the array detector. And this is how the object is detected when the radar is generated. Here, when the radar or the pulses are generated, then it is applied to the object detection or the clustering algorithm, and which is and the features are extracted from the algorithm, and the multi data acquisition or base finding are applied, base filtering is applied, and the DL method is applied, thus producing different this is how different algorithms. This is how the tracking and motion systems works in most of the cases, in the most of the self-driving cars, and we can see that different radar signals are generated. We can use different pulses. We can use different types of pulses for different detections, and etc. This is the simple system. This is the simple LiDAR system again. Here the laser uses different wavelength and detect the light, and the video amplifier is applied, and the signal processor and data processor is applied to the CPU, and the speed and range of the signals are being generated. This is a LiDAR scan. Of a warehouse. We can see how precise a LiDAR scan can be. When you take large amount of data points. In the similar way, the self-driving cars also uses large amount of data points to create a large map of the city, thus producing and predicting everything about the different data, different points in the cities where the accidents can happen, thus producing different data points can produce the system. The different data points can produce different outcomes. Here the cars can take every type of data which the normal human can use. Normal human can drive that car first and produce the data points to the car, and the car takes the data and produces very good algorithm, and produces the data very good algorithm for the user to make use of the data. The future of LiDAR can be used in integrating the LiDARs in virtual reality, and LiDARs can also be used as a threat detecting objects, where the LiDAR scanners in virtual reality, when we want to use the LiDAR in a game, they have to scan the whole game. They have to scan the whole room. Then the game produces the environment or background similar to the scan which they have taken, the scan of the room which they have taken, and producing the easy results, rather than different results rather than having different lesions. And lidar can also be used in the threat detection when like for example in car accidents, when the normal when the drivers when the cars are used, then the lidar, the human perception is only about 180 degrees or 270 degrees. Thus when we use a 360 degrees view of the cars, we can easily detect whether how the car is coming towards the other car and detecting the threat and accident of the car. Thus we can control the car, or thus we can control the car to avoid the accidents. Thank you.